The method of substitution that we use for indefinite integrals can also be used for definite integrals. Remember, a definite integral is basically when you have bounds here. So you would go ahead and integrate like you did using the u substitution idea. So the inside function u is x cubed plus 8, du is 3x squared. Rewrite it in terms of u, and then take the antiderivative, so add 1 divided by the power. The only thing extra that we have to do now is these bounds here have to match this variable of integration. So here, in the original problem, these are your x values. But if you're going to go ahead and integrate, plug in bounds for u's, then you have to make these bounds be a u value. So the idea is this. Your lower bound was x equals -2. So if I plug in -2 in for x here, that gives me -8 plus 8, which makes the new bottom u bound be 0. And then do the same thing with the upper bound. When x is 1, if I plug in 1 here, 1 cubed plus 8 is 9. So that becomes a new upper bound. So now you can go ahead and plug in the upper bound for u, the upper bound for the lower bound, and you'll get to 81 here. Now, if you want, instead of changing the bounds, you can go ahead and keep the x bounds, but then instead of writing your antiderivative like this, I'm going to go ahead and pull out that 1/9. You would have to plug in the u back in. So u is really x cubed plus 8. So if you want to go ahead and evaluate it in terms of x, that's fine, but then you would keep these original bounds. So this would be -2, and then this would be 1. And notice what happens. You'll get the exact same answer. So I'm going to pull out a 1/9. If I plug in a 1 here, this is 9. Minus, if I plug in a negative, this is 0, which also gives you 80. Oops. I forgot to cube it here. This is 9 cubes. This is also 81. Okay, let's try a couple of these. So let's go ahead and find the antiderivative like we normally would. So remember, when we have powers in the bottom, I want to think of it like this. This is really x cubed squared plus 1 to the -3. So my u is really x squared plus 1. My du would be 2x dx. So notice that's why you have that x dx here. So I need that reciprocal in the front. So I can rewrite it as u to the -3 du. So the antiderivative would be add 1, divide by the power. Now I need to come up with these new bounds that I'm going to use. So the original lower bound was x is 0. So the new u bound, if I plug it in here, u becomes 1. The upper bound was x equals 2. If I plug in 2 there, that's going to give me a u bound of 5. Once I do that, I'm going to go ahead and plug in the numbers here. So this would be 1 here, and this would be 5. I'm going to clean this up a little bit. I'm going to rewrite this as -1/4 u squared on the bottom. So this is -1/4. I'm going to pull that out. 1/25 minus 1. And remember, we talked about we can leave it like this if this is a short answer. Okay, let's try another one. So the next one here, your u would be 4x, because there is an antiderivative for secant squared, so your u should be the angle. Your du is 4 dx. So rewrite it. I'm missing that 4, so we need that reciprocal. So this would be secant squared of du. The antiderivative of secant squared would be tangent. So this is really 1/4 tangent of u. Okay, now I need to find those new bounds. The original bounds were x's. So when x is pi over 24, u becomes 4 times pi over 24, so your u is pi over 6. When x is pi over 16, if I plug it here, 4 times pi over 16 gives me pi over 4. So these are my new bounds. So the pi 6 goes here, and the pi 4 goes here. So I've got 1/4 tangent of pi 4 minus tangent of pi 6. Think back to your unit circle. This is 1. This is √3/3. Okay. Last one. So remember I said when you have numbers in the front, I usually like to go ahead and take it out. And this is what I'm thinking. Right? This is to the 1/2 power. So your u would be the inside function again. Your du is -2x dx. Notice again, there's your x dx, but we're going to do the reciprocal of that negative 2. So really this is going to become, the negative 8 stays. I'm going to put the negative 2 on the bottom, and then you have u to the 1/2 du. So I'm going to clean this up a little bit. So this is 4, add 1, divide by the power, and we need to figure out our new bounds. So the bottom bound was 0. If I plug in 0 here, your u becomes 4. The upper bound was 2. When I plug in 2 here, your u bound becomes 0. So this is 8/3. I would have 0 to the 3/2 minus 4 to the 3/2. This is 8/3, 0 minus, this is really the square root of 4 cubed, which is 8.